My name is Michael. I work at. Oh, what happened? Get back to. Yeah, there we go. I work at Akamai. I think most people know what Akamai is. It's. I'm surprised that some people do. Some people don't know. We are not known for our KVM interest. It's mainly known as a CDN business. But about 2 years ago, we purchased Linode. A lot of people don't know what Linode is. It's a small-ish cloud provider. Um, but we're mainly known for our CDN. But it kind of made sense for us. We got into cloud a couple of years ago. We bought Linode, and it's been fun. We're a medium, moderate-sized cloud with just about 500,000 VMs. So it made sense for us because we run a lot of software in the edge. So running virtualization in the edge was kind of a natural extension. And we've learned a lot in Akamai. So what are we doing with QEMU? We try to live migrate whenever we can, but like a lot of cloud providers our size, we simply cannot live migrate. We would like to. It's always best case scenario when we can because you get milliseconds of downtime, but most of the time we can't. We just don't want to keep spare capacity around that costs money. Sometimes we just can't because of silly things like CPU flags, security restrictions. Akamai is probably one of the most secure companies I've ever worked for, just security at every level. And we just simply can't live migrate. That holds us back sometimes because we want to roll out software much faster. We want to reduce the amount of stranded capacity that we have. We'd like to start rolling out software updates to hypervisors daily, weekly, and sometimes we just can't. It might because of some of the restrictions. Maintaining double the space or even fractions of extra space in the cloud is just not ideal. So we started looking into live updates. It actually surprises me quite a lot, even myself, my boss, when we started working on this, that live updates are now possible. So instead of live migrating, what is live updates? So this means as of April, I believe, some patches were merged into QEMU. So thank you to the QEMU community from Oracle. There was a demo of this working from a gentleman named Steve from Oracle. If you look that up in a KVM forum a couple of years ago, I believe, when it was still virtual. And another demo in Plumbers, I think maybe 3 years ago from Google, if I recall correctly. When we saw those presentations, we really paid attention that so live updates is the ability to update the kernel, the host kernel, and all of host userland without live migrating at all. So the VMs will never stop, and they just continue. There's a small amount of downtime, and I'll get into how that works in detail. But you're able to update the entire system minus firmware. You're not able to update obvious things like your BIOS and that sort of thing that actually do require a power cycle. But if you don't need a power cycle, you can live update everything in place without a live migration and still get the benefits of staying up to date, keeping your hosts up to date. So I'll get into exactly how that works. But it continues to surprise me how many people don't know that this is possible. It is possible today. And it potentially would save us as a business millions of dollars because we don't need to maintain all of this extra capacity. So again, thank you to the community for getting that merged just recently in QEMU. So how does it work? The key enabling mechanism to do a live update is some way to keep guest memory in place. So there's really only one way upstream in the kernel today to do that without changes or without carrying a patch set today that we're using now called persistent memory. This is a bit of an unusual use of persistent memory. This is usually designed for actual persistent memory, physically persistent hardware, persistent DRAMs, You can buy these kinds of DRAMs that will stay powered on, either with a capacitor or something like that, or some other mechanism that will actually persist your memory. But we're not doing that. This is what we call emulated persistent memory. So you start the VMs in some pre-reserved location in RAM before you start the kernel. You ask for this memory to be reserved. You run the VMs out of that memory, and then using the new feature that was just merged, again, just a few months ago, so it's pretty fresh in QEMU 9, called Checkpoint Restart. Again, that was some work from Oracle with the community. When you turn this on, you tell QEMU, instead of allocating anonymous memory, it now allocates file back to memory in this persistent location. So I won't go into the details of this. PMEM has been in the kernel for many years, so that's what we started with, and I'll talk more about that. But that's how you enable it. You then do a kexec operation. So when you're ready to do the live update, you switch to a new kernel. You tell QEMU, before you switch to a new kernel, you tell QEMU to do to save all the device state, IOMMU state, VFIO state is all preserved in a file the same way it would happen with a live migration or a suspend to disk operation. You save all of that state, synchronize all the file systems, quiesce all of the devices, and then perform a kexec operation. So this is right in the middle. You switch over to a brand new kernel, or potentially an older kernel, depending on what you need to do, and also potentially a brand new user land. So we do that as well in production. We're actually running this, rolling this out to production as we speak. We may update the entire user land if possible, if you need to. We often do need to. New kernel, all new user land, kexec into the new kernel, and then the VMs are sitting in persistent memory. So for potentially seconds that I'll describe later, they have been paused as compared to a live migration, where they may have, at the end of a pre-copy iteration in a typical live migration, they may have only been paused for milliseconds. In this case, they will have been paused during the entire kexec operation. So I'll show some timings on that in a little bit. But once the new kernel is taken over, we then just reverse everything that we did before. So bring online the new QEMU, potentially a new version of QEMU if it's a new user land. We have to do quite a lot of extra bookkeeping that we were not prepared for, so I'll get into some more detail there. We have to reconstruct all of the C groups, file descriptors for vhost if necessary, invert IO, and finally bring the new QEMU back online. So this actually works. I meet a lot of folks who even managers myself, who tell me every time, this works. Seriously, it does work. It's pretty cool. I didn't know, in fact, before this KVM forum, how much work was going into TDX and SEV. This is very interesting in that context too. We just had some talks on that, because you don't need to live migrate all of this massive amount of state potentially. There are so many use cases for this, even outside of the cloud, in other virtualized environments. So it actually works, and it's pretty cool to see when it's going. Just a little bit of this. Again, it works today. This is what the QEMU command line looks like. So if you've never started a VM from a file-based location, that's how you would do it, using a different memory backend in QEMU up here in the middle. And then you just need to specify a few capabilities and parameters to QEMU that are different, telling QEMU not to allocate from anonymous memory. So instead of that, it's allocating from the location that you chose in persistent memory. So it's pretty easy to use. That's kind of the easy part, but it does work. So how does it perform? This is where it starts to get interesting, and and delineates who can actually use this or not. So the kexec is fast. Bringing the VM online at the end is quite fast, but everything in the middle is where the headache starts. I've worked on kernel teams for a while, and most of the time I talk to my coworkers, I ask them, "Have you ever done a kexec before?" They've all said, "Yes, we tried it, but it took too long." That's a common answer that I get, and it's still true today. In order to do this, all of the devices have to be reinitialized from scratch, and that's often a deal breaker for a lot of folks. In our case, we started this on an internal cloud instead of going to our public cloud first. We control the applications that run on our internal cloud, so that's a caveat there. And we see device initialization times around 5 seconds. This is just vanilla devices that we don't control, that we have to work with vendors on, that go into our boxes. And our software can tolerate this. TCP can obviously tolerate this. Your TCP connections, if you have a live update and a VM is down and vCPUs are not running for that many seconds, they will be fine. So you're not going to lose any connections. It's just, but there are some weird problems that happen inside the guest, like time stopping. Time stops moving forward the entire time. So you have to think about that. If your application is sensitive to the management of time, you have to deal with idiosyncrasies like that. So, but yeah, this is a very long time for nothing to happen for a virtual machine. So if it's not able to deal with that, most software can deal with that. It's just a matter of working with the owner of the software. So then the next biggest problem is everything after system boot up. When we first started implementing this, we simply could not tolerate the amount of time it takes to go all the way up to system D and all the way up to user land. It's just so much wasted time. System D starts all the way over here at the end. We could not wait that long to bring a virtual machine back online. So we start our VMs immediately when the init MFS starts, as soon as possible. Just skip everything and start the VMs as soon as possible. So libvirt is gone. Systemd is gone. Everything's gone, so we have to deal with that. These are just kind of surprises that you have to deal with just for the cost to get the VM online as soon as possible. So that's not too hard to solve. It's really, the really hard problem is the device drivers. But that's where we are, and it does work. So 10 seconds or less, 5 seconds or less, depending on what system we're running on, we can get the VM back online roughly that fast. And we haven't had a problem with that with the VMs, the software running the VMs that we use today. That's kind of, if you were to use this today, that's kind of where we are today. So I'll talk more about that. I encourage questions. We've had a lot of very interesting discussions on how to solve this, and that should be quite a fun topic. So I mentioned some of the challenges. We have one more significant challenge to talk about. So when we started testing this, there were surprises that anyone else testing this would have to deal with. I'm going to save the first one to last because it will lead naturally into the end of the conversation. So serializing C group information. Because we're starting so early, we have to save all of the C group settings and restore them again. Anything that libvirt came up with when the VMs were starting, we have to reconstruct all of that, and that's not ideal. So ideally, there would be a libvirt solution for that. That would be great. I think I mentioned we have to recreate file descriptors for VFIO, and every queue in a multi-queue VirtIO NIC has to be, all those file descriptors have to be recreated. We started doing loop testing. That was fun. So instead of, the idea here is that if you get really good at live updates, you live update way, way, way more often than you live migrate. So we have to simulate that. So when we started doing this, we would just run live updates in a loop for days, hundreds of times, over and over and over again. And you have to do this because if something goes wrong in QEMU, some tiny little bug that you've never seen before, well, now you have a VM running forever. It may never be turned off ever in the future. We have VMs running for 5, 6 years without ever being turned off, which sounds crazy, but these VMs exist, and you have to be prepared for that. So there were many cases where a device, a physical device, would be fine after 50 or 100 live updates, but the 200th time it was reset, it gave up because whatever the firmware author wrote for that device was just doing something that happened to persist across 200 resets, and it actually stopped working. So that was a surprise. You have to deal with that. I mentioned this one already, systemd. We decided to just skip it. I've seen articles about people starting systemd in the initramfs, which is just more software in the initramfs. But we need to skip as much as possible to get the VMs online. So whatever you have to do is okay. We found a lot of firmware bugs, and we don't have the time to go to every vendor and say, hey, we found a bug in your firmware after 200K execs, can you fix it? And a lot of times they're just like, well, this was designed to be power cycled. Why are you contacting us? Leave me alone and don't ask me for it. That's a common response when we reach out to a vendor in this kind of context. That sucks. I think I mentioned timekeeping as well. So that is a complicated problem to deal with. If there were a way in KVM to kick QEMU and somehow signal to KVM clock or something to correctly adjust for whatever the TSC is telling the guest what its time is, if there were an automatic way to do that, that would be super helpful. So a lot of the things I'm bringing up here are kind of call outs to the community that if you do this in production, this is what's going to happen to you. Time just stops. The clock just doesn't advance 5 seconds later. So if there were a way for KVM to, through some kind of an upcall or whatever, to get the guest to update its clock accurately with the amount of time that has actually passed, that would be great. So that's a problem that happens today. Regardless of the clock source, if I remember correctly, that's a problem today. Another very important feature of, and this is quite important for us with live updates, is NUMA support. NUMA support, NUMA pinning, and CPU pinning are critical, very performance critical for us. We have to have it. So what we do is that we may have VMs running for years. We need to move VMs from systems that don't have live updates enabled and live migrate them seamlessly to a live update compatible system that can then finally perpetually run live updates. Old VMs, we have to be able to support that. So we have patches for that. Thank you to the community again for working with us there. We quite a lot of challenges. So again, talk to me offline if you're curious about some of that. And this is my last slide. So persistent memory is quite a challenge to deal with. We're representative of a smaller cloud provider, and we don't have the ability sometimes to dedicate SKUs, whole bare metal SKUs to specific products. So when we want to differentiate some VMs from another, as our cloud is developing, and I know this is true, I used to work at DigitalOcean and IBM, as the cloud gets bigger and organically grows bigger, you don't always have the ability to dedicate specific types of hypervisors to specific products. Sometimes that's just not even possible. So when we do, this matters particularly for NUMA support, we need to be able to move a VM from one NUMA node to the other live. We need to be able to swap VMs live while they're running out of persistent memory. And we need the ability to resize the persistently allocated region live as we change the definition of what that hypervisor is without having to tear it down. So there are a lot of solutions for this. I think I'm running out of time, so please come and talk to me offline. There are a lot of solutions for this on LKML that are quite interesting. And I think I missed a column, particularly the case where we need to move VMs between NUMA nodes on the same host. That's quite common because our hypervisors are not dedicated to specific products. So if we send a customer's virtual machine to one NUMA node, we can't live migrate sometimes, so we need to be able to basically defragment capacity across the fleet of machines so that we can make space available on an individual system that might be available in the future for a future VM that might arrive in that slot. So we have to do cross-host bin packing sometimes. And if we can't move VMs between NUMA nodes, then we can't do that bin packing. And if we can't do that, then the persistent memory solution gets in the way. So again, we're using PMEM at the top, and there are some solutions, additional solutions here that might work for us. So that's the end of my time. Please, any questions? I think we have a minute left. Oh yeah, thank you. Yeah, so we have a few minutes left, and please do find me. I continue to be surprised about how many people don't know that you can live update today, and so it's quite interesting. Go ahead.
Yeah, so the time progression thing definitely should, if I understand the problem correctly, that definitely should be workable. Maybe there's just something in QEMU that it's not adjusting a TSC offset or something like that. But to understand the problem, are you saying that time, that live update time, for example, 10 seconds just disappears and the VM doesn't see it advancing? Is that
it doesn't see it advancing, exactly.
Okay,
exactly, yeah.
We should take a look at that because there definitely is a way to apply an offset and serialize that across K. Exactly.
There is, in fact, in the clock implementation in QEMU, it applies an offset at startup, but there's no way to reapply it. And so in QEMU specifically, so it's just not a complex fix, but it is.
And there are a few more things I just want to point out. So in your case, you're not doing device assignment. There's a whole nother can of worms if you want to do device assignment and state pass-through, and I think that's another part of this problem.
Yeah, and I think that's representative, to answer that question, it's representative of a lot of cloud providers that are this size. All of the clouds I've worked on in the past didn't use it, and so as a community, getting live update support more easier to use, we have to think about that.
And those characteristics that you speak about, like swappable and all those kind of things, become less interesting or even undesirable when you're starting to do device pass-throughs.
True. Yeah. Right.
Just jumping back to the time thing, don't you have to solve the problem of just that's too long of a blackout period, though? Like, yeah, you can make it look to the guest like the time was correct, but if you don't have a response for 10 seconds, you're going to have so many other problems downstream from that.
We haven't found that to be a problem. We were surprised by that. I mean, I was expecting that when I first started doing this to be a big problem, but most software can handle it. I mean, most software can handle it. There are some isolated cases, yeah. You do have to, the answer is yes. If it's a, if a customer has a contract with your cloud for millions of dollars and they can't handle it, then you're going to have to deal with that.
The time problem is surely not that different from what you face if you do save and restore to disk.
Correct.
Because your VM is running, it's just not running for a very long. So in that case, when we restore from a saved file, there's a QEMU guest agent option where you can just poke it to update its system clock. I don't know if that is
I have to look into that.
Useful or not. My other thought was all the tricks you're doing in the init ramifest to bring things up before systemd and libvirt. That's very brave.
Yes, it was a pain in the you-know-what.
Particularly with the C group stuff, I'd be pretty worried that systemd might decide to just blow away the whole hierarchy and put it back the way it wants.
It tried to.
Starts up.
It did try to. We found a way to hide ourselves,
Yes.
but it did try to. Yes, and in fact, as well as libvirt, we are cheating and not working with libvirt instead of against it. So I think I spoke to Martin about that. Ideally, there would be some kind of a libvirt binary that didn't require bringing in the entire libvirt userland that could just get us going, and then when systemd came back online, it would then reestablish its knowledge of the VMs.
Yeah, it'll be interesting. I mean, I think in the initRD, on Fedora at least, you've got systemd in the initRD. It then re-exec, when it finishes the initRD, it then re-execs the real systemd. So
yeah, that's a problem. It adds another second. Like every second that you add, even 1 second, even a half a second that you add is too much. And so unless we can find a way to really just whittle apart systemd into some essential component that would get out of the way and just have the startup, it's a hard problem. It's such a big piece of software. So good questions, yeah.
I was wondering, so this looks definitely very impressive, and just to echo some of the points that were brought up earlier with how like 5 or 10 seconds downtime might be an issue for some
It can
workloads.
be, yeah.
Have you been following some of the other things that have been going on with like local exec or live migration for QEMU specifically that's being discussed at the moment? Like as a little brother, you don't get the kernel exec, but on the other hand, you get basically a lot less downtime and a few other headaches that you don't need to solve.
Yes, that was merged. Oh no, pieces of it were merged in QEMU from Steve.
The other stuff is still, I think, under discussion.
So that's a good. I mean, I guess that'll round up, maybe round out our. Hopefully, we have more time. I don't know how much time we have, but there is an extension to the changes in QEMU that don't use kexec. So everyone check that out. That's they're good patches.
Unfortunately, we are out of the time. So
All right, thank you.